This is a flake from Quartz Lake, Alaska. It's made out of obsidian, and we want to understand where the obsidian came from geologically. We use X-ray fluorescence to characterize the amount of trace elements such as nickel, copper, strontium, and rubidium that are contained within a material. Determining the chemical composition of these materials may help us identify what the material actually is or where it originates from. The XRF emits photons from the detector at a defined rate of energy in kilovolts and amps that pass through a small window at the top of the machine and into the target materials. The photons cause electrons to become unstable, and they move generally from a higher to a lower shell within the atom. This movement of electrons creates the emission of energy by another photon that is specific to the molecular weight of each element. This energy emission is fluorescence, and it is what we measure in the detector as the energy is bounced back into the machine. For certain materials like volcanic rocks such as obsidian and rhyolite, we like to target a very defined range of trace elements. We place a filter that has specific concentrations of copper, titanium, and aluminum into the machine that can block ranges of energy released from the detector into the materials. This allows us to measure our target elements much more efficiently. The software shows concentrations of elements that are being detected in a material by the height of the peak within a spectrum. You can see here that the relative abundance of an element in a material is represented by taller and shorter peaks of the spectrum. In the case of volcanic rocks, we have been able to calibrate the software to track the abundance of elements in parts per million. Here's an obsidian nodule that's from gravels around Wrangell St. Elias. We call this the Wiki Peak source. Our obsidian flake from Quartz Lake sources to this area. Materials like obsidian and rhyolite, we can compare the spectrum peaks and the parts per million abundances to known geologic sources. This allows us to track the movement of obsidian and rhyolite artifacts from its original geological location to archaeological sites. These movements of materials tell us about a movement of people and trade and exchange patterns and connectedness of groups through time.